All right, in this lesson, we're going to look at something called partial fractions or partial fraction decomposition. All right, so what's going on here is when we have a situation where we've got an integral like this. Let's check this integral out. Here we go. Okay, 1 over x squared plus 5x plus 6. Can we integrate this? Well, not so easily because this is, a second degree polynomial down here. We could try to say u is equal to this, and so du would be like a 2x, but we don't have another expression that has an x in it. So not going to be able to do u substitution. Okay, that doesn't work. Trig substitution is not going to be too nice because, we're looking for a square root of like a squared plus b squared or something like that to get trig substitution. So we do notice, though, that x squared plus 5x plus 6 is x plus 2 times x plus 3. So this fraction here can be written like this. And it would be nice if we could figure out that we can break it up like this. Because if we can break it up into this fraction here with an x plus 2 and an x plus 3, this would be the common denominator here, right? Then we could integrate both of these two things, right? We could take this situation, break it up into two integrals, and then integrate each one, which is nicer because it's just x to the first, right? We can handle that, so, okay? And we get a couple logs. So this process is called partial fraction decomposition. So here, I just threw this out there. How do we get that? How do we know that this is just 1 over x plus 2 minus 1 over x plus 3? Well, that takes a little bit more work. Okay, so we're going to take this. We want to decompose it or break it up into these partial fractions, these two little fractions that add or subtract to make this big fraction. All right, so let's see how it works. Okay, so I got an example for you here on the handout that just kind of breaks it up for you. Okay, so here we have an integral with a fraction in it, some polynomials on top and bottom. So first thing we want to do is we want to look at this bottom and say, can we factor that denominator? Well, yes, we can. All right, x squared plus 11x plus 18 can get factored into x plus 2 times x plus 11. Okay, so what we're hoping to do, what we're hoping we can find, is we can find two fractions, one with a denominator of x plus 2 and one with a denominator of x plus 11. We're just kind of hoping that we can break this up. So we're going to kind of work backwards here. Okay, so we're going to set this up. All right, we're going to set it up. We want this to become this form. Make sense? A over x plus 2 plus b over x plus 11. Then, if we want to get a common denominator here, let's see. How would we make this into this? Well, need to multiply this by x plus 11 on top and bottom, right? This times x plus 2 on top and bottom, okay? And that would give us this common denominator, right? So we're going to multiply by x plus 11 here, multiply by x plus 2 here, okay? Now I got a common denominator. Still, these are equivalent, right? So now this could be added together, trying to put this together to make one fraction out of it. And so we have a times x plus 11 plus b times x plus 2. And the denominator is x plus 11 times x plus 2. Okay, what do we just do here? Let's look at this whole line, okay? So these are all equivalent expressions. I don't know what a and b is. That's what we're going to have to find out. But notice the denominators, these denominators at the beginning and the end are the same. So here we have x plus 2 and x plus 11 multiplied. And the numerators would have to be equal also. So that's the key. So we're going to say x plus 20 has to be equal to a times x plus 11 plus b times x plus 2. See how that works? And so we're just going to kind of rearrange this now. We'll distribute the A, distribute the B, and then let's put the x's together. So we'll kind of take these two x terms, put them together, ax plus bx, and I guess, right, and we'll factor out the x, all right? So a plus b times x is the same as ax plus bx, of course, right? And then I've got 11a and 2b, and we'll kind of bring that on over here, and no factoring can really happen there. Just rearranging and a little factoring. So what's going on? Well, we're saying that a plus b times x plus 11a plus 11b is equal to this expression. Well, notice the forms. Here we have 1 times x, and then we've got this constant 20. Well, over here we've got a plus b times x, and this right here is a constant. We're going to find out what a and b are. A and b are just numbers. They might be algebraic expressions, but that's most likely just numbers. All right, so we want to set these green things equal to each other. 1 has to be equal to a plus b, and 20 has to be equal to 11a plus 2b. Well, that's a system of equations, right? So these two equations with an a and a b. And we can work with that, right? Okay, going back to like Algebra 1 kind of style there, all right? Oh, look, they both have a 2b in it. That's kind of nice. So we could just subtract these equations. Second equation minus the first equation will give us 18 equals 9a. All right, subtract the first equation from the second equation. We get this. And so a is 2. And we can plug that back in and find out that b would have to be -1. All right? So solve the system. Pretty straightforward there. We get a and b. Well, what does that mean for us? That means our original integral here is equivalent to this, where a is 2 and b is -1 minus 1. Okay, so we found out what a and b are here. That's what we were going for here. We've rewritten the integral. Now, this is a fairly easy integral to work with here. We can pull the 2 out, and we've got, 1 over x plus 2. That's going to be a u prime over u is what that is, okay? Use some u substitution. And so we've got natural log of x plus 2 minus the natural log of x plus 1. And don't forget your plus c. There it is. So when we can break the fraction up, it becomes easy to integrate. So that's the process, all right? So again, just a quick recap. If we can factor, we're going to write it as 2 fractions, or sometimes 3 or more. And we're going to find out what these mystery numerators are by doing a little bit of algebra and getting a system of equations, okay? Let's look at some other situations there. All right, so here's one that we're going to try to factor and break it up. And so if we factor x, the denominator here, we're going to get x times x squared plus 2x plus 1. And that denominator there is x plus 1 times x plus 1, or x plus 1 squared, right? So this guy can be written out as 5x squared plus 20x plus 6 all over x times x plus 1 squared. Now these are linear factors. They're linear because in this factor, it's just x to the first. This is the biggest degree. This factor, x plus 1, is just x to the first. There's no x squared in here. And so those are linear factors, all right? So when we have linear factors, we're going to break this up into 3 fractions. And the numerators are going to be first or 0 degree, really. They're going to be constants, okay? So, well, 3 fractions, it looks like we only have 2 different factors. Well, one factor is x, one factor of the denominator. Another factor is x plus 1. And then another factor is x plus 1 squared. All right, so when we have these repeating factors, a factor squared is like that, we've got to do the first degree and the second degree. If it was third, well, we'd have to have the first, second, and third degree. If this was like a 3 here, okay? And so that's what we're hoping for. We're hoping that we can break this up. So we'll forget the integral for just a second, and we'll just work with this this expression here, all right? So what we want to do is we want to combine this into one fraction so that we get an equivalent fraction to this, okay? So let's see what we got. Well, we're going to have to multiply top and bottom here. I've got an x, but I need this common denominator, so I need to multiply this by x plus 1 squared, right? Top and bottom. So I'm going to have a times x plus 1 squared. Then we're going to multiply top and bottom here. We got a single x plus 1. But in order to have a denominator that looks like this, I'm going to need to multiply by another x on top and bottom and multiply by an x plus 1. So we're going to have the b times an x and an x plus 1. Really, I'm multiplying top and bottom there, right? Okay. And then here, going to multiply top and bottom here by x. I already have the x plus 1 squared, but I need the denominator to have x. So we're going to multiply top and bottom by x, all right? In fact, maybe I'll just kind of write this out. Multiply top and bottom by x. Multiply top and bottom by x plus 1 here. Here we multiply top and bottom by x plus 1 squared. Right? All right. So we have some experience from Algebra 2 and pre-calculus doing this kind of thing. Okay? And so this last one would be c times x. And that whole thing is over x times x plus 1 squared. So what's going on here is these things are all equivalent. This fraction is equivalent to this fraction, is equivalent to this fraction. Again, I don't know what a, b, and c are. So what we're going to need to do is we need to simplify this numerator here. And then this numerator has to be equivalent to this. So we'll get all the x squared terms and the x's and the constants, and we'll rearrange them and we'll get a system of equations here. So time for a little algebra here. All right, we're going to multiply this thing out. We've got a times x plus 1 squared plus b x times x plus 1. All right, let's just simplify this out. Going to be a little bit of work, but we've got x squared plus 2x plus 1 when we square that. Distribute this x. We've got x squared plus x. All right. And now we're going to distribute here and then get all the like terms kind of together. So we're going to have an ax squared. Going to have a bx squared. You're going to have, that's it. Okay, so that's our x squareds. Then we're going to have some x's. So we'll have the 2x times the a. So that's a times 2x, whatever order you want to multiply that in. We got a bx. And then we've got a cx. Okay. And then constants, remember a, b, and c are constants. We're going to have an a times 1, and that's the only constant there. All right? Now, let's do a little factoring. Here we have x squared times a plus b. We factor. And then we've got Pull out the x. We've got 2a plus b. Oh, I forgot the c there. Don't forget the c. Plus c. And then we've got our plus a. All right, and this thing needs to be equivalent to this expression up here, right? Because the numerators are all equivalent, right? So, well, what does that mean? We have 5x squared plus 20x plus 6. Let me make that a capital A. Don't know what I was doing there. Thinking and talking at the same time. It gets challenging. Okay. So, see our equations here? We've got a plus b has to be equal to 5. That's our first equation. So let's come over here. Let's write these out. We've got a plus b equals 5. We've got 2a plus b plus c has to be equal to 20. Now notice we're getting rid of the x's, right? Because we're just looking at the coefficients. And then last but not least, a and 6 are equal. Well, that's a nice one. That's going to make it all fall together. So we already know a. Great. Well, let's take this system here and let's figure it out. We know that a is 6. Since a is 6, then b, we've got 6 plus b equals 5. So obviously b is -1. Little substitution here. We have 2 times 6 plus -1 plus c equals 20. So that's 12, 11 plus c is 20. So c is 9. We found a, b, and c. That's what we're going for. So we can plug that back in and solve the integral. That's our ultimate goal, is to solve the integral. All right, so if we come back up here, we've got 6, -1, and 9. So this is going to become the integral of 6, -1, and 9. Those are our numerators. X plus 1, and x plus 1 squared. And dx. All right. Well, that is an integral that we can perform there, right? So we end up with, integrate each of these terms individually. So we get 6 times the natural log of x minus the natural log of x plus 1 and plus 9. Now, let's see how we're going to integrate this here. We got our u substitution, all right? So we've got the integral here, right? We're thinking integral of this, okay? U substitution, u is x plus 1. So du is just 1 dx, right? So that's a nice simple substitution, right? So think of this as u squared. Okay, so how do we, that's u to the -2, all right? So u to the -2. We're going to add 1 to that, u to the -1, add 1 to the exponent. U to the -2 becomes u to the -1, which is 1 over x plus 1. And then times -1. So it's going to be negative. All right. In other words, 6 natural log of x minus the natural log of x plus 1. This will be a minus, that's a times right there. Minus 9 over x plus 1. And don't forget your plus c. Plus c. There we have it. So that's the process, kind of a clever one. Taking a big fraction and decomposing it into smaller fractions that we can deal with, okay? Well, let's look at one more here, one more example. What happens when we have a quadratic factor here? All right, here we got a couple quadratic factors. So first thing to do is to look at this denominator here, x squared minus x squared plus 4. You want to make sure that you factor it as much as possible, and I don't think this is factored as much as possible, right? We can pull an x out of that first term there, first factor, I should say, and we get x times x minus 1 times x squared plus 4. So make sure you factor it completely, even if it looks like it's factored there. All right, so we can break that up. And then we're going to take this fraction, 2x cubed minus 4x minus 8, all over that factored version. Right? And we want to break this up into 3 fractions. Is what it's going to be. All right? And so we're going to have one fraction that has a denominator of x, one fraction that has a denominator of x minus 1, one fraction that has a denominator of x squared plus 4. Now, we want this one to be, it's going to be a times a over x, just a first degree there. I'm sorry, first degree on the bottom, 0 degree, or a constant on top. Then we have b, first degree on the bottom, constant on the top. Now this one is a second degree expression. So in order to integrate, that's our ultimate goal. We want to integrate this thing eventually. We're going to need to use a log, right? We want some use substitution. So this is second degree. So we're going to need a first degree expression up here. In other words, something times x plus something. And again, these a, b, c, and d, they're just mystery numbers that we need to find. But the key here is that if this is second degree, this needs to be first degree. Okay? This is a quadratic, this is linear. All right? If this was cubic, this would need to be quadratic up here. Okay? That's how we're going to use our use substitution in the end, you'll see. All right. Well, let's go ahead and write this expression. How would we simplify this? Okay, and as you saw, what we care about is what we're going to end up with the numerator. Okay, and so we're going to multiply top and bottom here by the other 2 terms. Okay, and that'll leave us with a times x minus 1 times x squared plus 4. And then we have b times the x and the x squared plus 4. The 2 factors that are not in the denominator. Okay. And one more, we have our cx plus d. And we're going to multiply that by the other 2 factors there. All right, so it's going to be x and x minus 1. Something like that. All right. We'll call this our basic equation. What equation? Don't have an equation yet. Well, got to finish the equation. This side is 2x cubed minus 4x minus 8. All right. So that is our basic equation. That is kind of the key. That's what we need to solve to find a, b, and c, and d. Okay. Another way to think of what happened here is if you multiply both sides by the common denominator, which is this. We multiply this side by x times x plus x minus 1 times x squared plus 4. Multiply this by that. Well, some things cancel and we're left with that. All right. Now, this is some pretty ugly expressions. We don't want to multiply all this out, all right? So we're going to get another strategy, a better strategy, and probably a strategy that you want to use instead of simplifying that, okay? This equation has to be true for all values of x, right? Doesn't matter what x is, this has to be true. So to make our life easier, we're going to choose some clever x's. We're going to say let x equals 0. And what happens when x is 0? Well, when x is 0, this is b times 0 times something, 4, and that just all goes away. This is 0 times negative 1 times something. That whole thing goes away. So when x is 0, those two terms go away, and we're left with this first term. So let's write it out and see. This is going to be a times negative 1 times 4. And that, we'll get a couple zeros there. And over on this side, we get 0 minus 8. All right, so we end up with negative 4a equals 8. And that tells us, negative 8 actually, that a is 2. Great. Well, now we're going to do the same idea here for the other two terms. Okay, so let's choose, how about let x equal, well, what's going to make these guys go away? That's going to be if this term, see x minus 1 is here, x minus 1 is here, but there's no x minus 1 here. Okay, so let x equals 1. That will make those two terms disappear on the end. So what do we end up with? On the right side, we get 0 plus, now x is 1, so we've got b times 1 times 1 plus 1 squared plus 4, which is 5. And this last term here is 0. Okay? And on the left side, we plug in 1 to here. And 2 times 1 squared minus 4 times 1 minus 8. All right, so that's the idea there. That's going to give us negative 10, right? And 5b. So that tells us that b is negative 2. Then last but not least, we want to find c and d here. All right, so let's go ahead and make these two disappear if we can, but notice we can't. There's no number you can put in here to make this disappear, real numbers. No imaginary numbers allowed here, all right? So we can pick any two x values here. We're going to need to pick 2 because this is going to give us a system for c and d, 2 variables. So we'll pick some convenient ones. 2 and negative 2 are kind of nice because of that squaring, so we'll do that. So we'll say let x equal 2. And in that basic equation becomes, plug in 2 here. We get 2 times 8 minus 8 minus 8. Well, that's nice. That's 0. And then we get a times 1 times 8 plus b times 2, x is 2, times 8. By the way, we're just getting these, using these terms up there. And then lastly, we have cx plus d. And plug in 2 times 1. 2 times 1. Now, we have one more thing we know. We also already know a and b, right? So we can plug in a and b. A is 2, b is negative 1. So let's go ahead and substitute those. A is 2, and B is -2. All right, what do we end up with here? We've got 16 plus -32 plus... now I just realized we actually know what this x here. This x is 2, right? So let's distribute this 2, and so we have 2 times 2c. That's going to be 4c, and then 2 times d. All right, equals 0. And that's -16. Add that 16 over. We're going to get 16 equals 4c plus 2d. And how about if we divide everything by 2? We'll get, just to keep it a little simpler, 2c plus d. All right. Now we need a different equation that has a c and a d in it, because we're going to need a system to solve this. So we need to pick another x. It can be any x. It doesn't matter. Pick something small. Let's go with maybe -1. So let x equal -1. You could do decimals if you want to be crazy, but -1 would be good here. Just something we haven't used. So let's plug -1 into all this and see what we get. All right. When we plug -1 into here, we get -2. We get +4. So -2 plus 4. And then -8, that's going to be, what, -10. So we get -10 from the basic equation there. Now, we know our a value and our b value. Okay, so we've got those. So we're going to plug those in as we go here. All right. So a is 2, and we're plugging in -1 here. So this equals 2 times -1 minus 1, -2. Plug in -1, we get 5. -1 squared is +1, right? Now let's come over here. B is -2. -2. So we got plus -2 times x is -1, and then 5. And then we've got c, which we don't know. Looking at this last term over here as we squeak this in here. Cx plus, oh, we do know x. So c times -1 plus d. Careful with those parentheses. Just copying this here. X is -1 times -2. All right, there it is. Clean it up carefully. We've got -20, right? We've got 2 times 5, which is 10, positive. And that's a +2. We'll distribute that out there. That's a -2c. So let's make this a -2c. And then a plus 2d. All right, so we're getting there. So this guy is a -10. Add it over, it becomes... And you know, I just caught a mistake. You may have caught it a while ago. I said, oh no, he's going downhill there. That's supposed to be a -6. Go plug it into our equation, and that's a -6. I'm glad I caught that before we went too far. All right. You're probably yelling at the video saying, wait, no, that's wrong. Okay, we caught it. Good news. So anyways, this is going to be a -10. Add it over there, and we get 4 equals -2c plus d, 2d. And how about we divide both sides by 2 just to make it simpler. All right. Now we're kind of going down this rabbit trail here. We've got these two equations that are a C and a D equation. So let's solve the system. 8 equals 2C plus D, and 2 equals negative C plus D. And if we subtract these equations to make the D's go away, we get 6. And 2C minus negative C would be 3C. So C equals 2. Great. And easy enough to plug that in there. So we have 2 equals negative 2 plus D. So D is 4. Okay, good news there. And that's what we were going for. So we now know that A is 2, B is negative 2, C is 2, D is positive 4. Yes, these take up a lot of paper and a lot of room, so we won't have many of these on the assignment. So, all right, so let's rewrite our expression up here. Okay, so this becomes, let's just come over here and write our integral out. The integral of 2 over x, we're using this form right here, 2 over x, plus b, we said b was negative 2, so really this is a minus 2 here. So minus 2 over x minus 1. And then our cx plus d are 2 and 4. So we have 2x plus 4 over x squared plus 4. Now, when we go to integrate this, if this is our u, a little tricky, this is not our du, so we actually need to break this up into 2 equations using this numerator. So we're going to make this 2x over that numerator, 4 over this numerator, all right? So we've got to break that up one more time there, all right? So plus 4 over x squared plus 4. All right, we're almost there. Finally, time to integrate here. So integrating 2x, we have 2 times the natural log of the absolute value of x minus 2 times the natural log of the absolute value of x minus 1. Then plus, now we've got a little u substitution here. If this is u, then du is x dx. Actually, I'm sorry, 2x dx. Well, that's good. We got 2x up here and our dx. So this is u, and this is du. That's good news. So that's just going to be the natural log of x squared plus 4. Which we don't really need absolute values around that because x squared plus 4 is always positive. And then last but not least, this one, we can't use u substitution here. However, if you remember arctan, all right, so this is in the arctangent form, all right? So we have u squared plus a squared, all right? And if you look that up, then that arctan, we have that a value, because this is a squared, times the arctan of the square root of one over the square root of the other. And we're done. Whew. Okay, long process. Okay, I want you to kind of understand the big idea. A few little twists and turns with that quadratic. That made it a little tricky. A lot of arithmetic to be careful with. Okay, but an interesting process there to kind of get a handle on. All right. Well, we'll do, again, a few of these here on the assignments. You can go give it a try there, and we'll try to avoid some of these that get too crazy, but understand this technique is useful.